Scientists have recently uncovered an anomaly that defies expectations. Right now, a group of 7 comets hurtles in the direction of the Sun, set to reach it mere days apart come October 25. No such event appears in any historical records, yet the element that renders this finding profoundly disturbing emerges from another detail. 3 Atlas, originating from a completely separate stellar realm, will execute its nearest pass at precisely this interval. Such alignment carries probabilities so minuscule they border on the impossible, except if an unseen influence is orchestrating the convergence. Could this represent more than a mere transit, perhaps the onset of a darker phenomenon? This evening, we shall probe all conceivable explanations and ponder influences that transcend established scientific knowledge. Remain with us to the conclusion to uncover 3 Atlas's true impact on our solar domain. Part 1. A Heavens Teeming with Intruders. During an ordinary year, observers might glimpse just 1 or perhaps 2 luminous comets deserving mention. Many seasons slip by offering scant more than faint blurs through scopes, thrilling solely the staunchest seekers of these wanderers. Yet in 2025, the cosmos seems intent on staging a grand display. Allow me to present the ensemble of entities prompting experts to verify their figures repeatedly. Pan-STARRS, SWAN, Stereo, Atlas K1, Atlas G3, Lemon, and NEAT. These 7 unique comets, each bearing frozen and stony payloads from the solar system's remote fringes, converge over a span of mere months, evoking an unplanned gathering among celestial bodies. Consider the scenario like this. Suppose 7 acquaintances from distant regions all arrived at your home during one shared weekend, insisting utter ignorance of each other's plans. Feasible, certainly. Mere chance? Undoubtedly. Provocative enough to spark doubts about covert summons? Indeed, this grouping produces what experts term a swarm effect. Numerous comets packing into a brief viewing period. Viewed from our planet, the arrangement appears nearly deliberate, as though an invisible force guided them inward. Prior to delving further into this stellar enigma, we must set forth basic principles. Perihelion denotes a comet's minimal distance to the Sun, that instant when radiant warmth converts far-off icy masses into dazzling streams of vapor and particles. Closest approach indicates proximity to Earth, dictating if detection requires field glasses, an observatory instrument, or unaided sight. Magnitude gauges luminosity. Dimmer readings signify greater visibility. A value of 6 offers scant detectability without ideal conditions, whereas 0 matches the most radiant stellar points. The pictorial proof proves persuasive. Envision a graph depicting standard comet entries dispersed over years, points dispersed haphazardly through chronology, akin to scattered droplets on a walkway. Contrast that with 2025, 7 points huddled closely, resembling a scattering of small spheres from a loose grip. The configuration stands out starkly. In usual times, hobbyist stargazers devote seasons searching for capturable sites. Now, abundance overwhelms them. Online communities for imaging hum with shots of various comet streams crossing identical sky sectors. Digital networks surge with sequenced clips, capturing an apparent synchronized dance among the stars. Yet at this juncture, our inquiry shifts to a captivating development. As these 7 comets trace their foreseen paths, another presence lurks amid the void separating worlds. 3 I-Atlas, marking the 3rd verified extraterrestrial body identified within our solar expanse. Distinct from the septet forming our comet reception line, this interloper did not originate locally. It coalesced near a foreign sun within a dissimilar orbital arrangement, traversing our vicinity via a singular hyperbolic path. The synchronization provokes inquiries that haunt experts through sleepless hours. Might it truly be happenstance that the solar system's most aberrant comet season in living recollection aligns with a visit? Is it possible that an outsider from the stars has joined by chance, or might a purposeful hand be involved? In our probe into this matter, we'll draw a firm line between solid evidence and conjecture. You'll find reliable details in the orbital records, sighting records, and luminosity readings we share. For ideas that step outside established knowledge, we'll flag them explicitly as guesses. Our goal isn't to force-fit ideas, it's to chase clues to their logical end. The benchmark we apply is straightforward yet demanding. Should 3I Atlas link in any way to this cluster of 7 comets, the tie ought to show up in clear traces. Alignments in timing that beat random odds, paths in space hinting at design rather than luck, contacts between bodies that we can gauge and confirm. We seek no faint clues or fuzzy shapes needing loose explanations. Instead, we pursue hard, countable proof capable of swaying even the stoutest stargazer. The sort of findings that turn hunches into accepted truth. This inquiry's importance reaches past mere scholarly interest. Should these 7 comets have come alone, obeying only the stark rules of path calculations and chance finds by scanning scopes, then we observe an impressive yet ordinary sky alignment. The cosmos stretches wide enough to now and then stun us with groupings that seem profound, yet prove mundane. Yet, should some outside pull, be it from gravity, electric fields, or an unknown factor, have steered these bodies to align in time, we face signs of powers at work on levels we scarcely grasp. Powers that might overhaul our grasp of motion across the void. Ponder the fallout. 7 comets aligning without cause defies the steady physics ruling our star realm. Each path narrates a tale. Each course bears marks from the influences that molded it. If any director rerouted these travelers to their present routes, those marks must stand out. The wanderer from beyond adds fresh enigma. 3I Atlas hauls frozen water and grit born in the blaze of a far-off sun, toughened by space rays over eons of travel. Its makeup offers hints to world-building in alien star domains. Its actions nearing our star expose how foreign stuffs react to solar blaze. But suppose its timing holds less randomness than thought. Suppose the very power that may have rounded up 7 homegrown comets also drew this star-crosser to our domain just when needed. Queries branch out endlessly, each solution birthing fresh riddles. How might we spot such steering? What device could span space's huge gaps to sync bodies so exactly? And if such syncing holds, what reveals about our starry surroundings' real makeup? As we gear up to scrutinize each player in this odd 7-comet troupe, keep in mind the cosmos seldom yields its hidden truths without a fight. All advances spark from a sight that jars the norm. All leaps forward ignite when one probes why matters aren't as plain as they seem. The cluster has shown up, bringing riddles that could upend our views on solar system dynamics. Yet before diving deeper, we must greet our 7 arrivals right and grasp each's distinct traits. Chance or link. The proof lies ready, and the gauging begins now. Part 2, the lineup of the cluster. Time to encounter our 7 arrivals one by one, since each holds its private saga of finding and stellar trek. Imagine a gathering of suspects, each claiming innocence, yet inexplicably converging on the very site of the incident. Leading the pack is Pan-STARRS, our premier and most luminous contender. Unearthed by the Panoramic Survey Telescope and Rapid Response System, SHAE, a Hawaii-operated celestial watchdog that has transformed the pursuit of comets. This entity is set to achieve visibility to the unaided eye for those in the Northern Hemisphere. The observation period spans from the end of March until May in 2025, affording ample time to track its inbound journey. The allure of Pan-STARRS lies not merely in its prospective brilliance, but in the configuration of its trajectory. This comet's route positions it near the plane of Earth's orbit, rendering it straightforward to spot from densely inhabited regions. To those inclined toward spotting designs, such approachability borders on the suspiciously opportune. For an entity purportedly drifting in from the distant fringes of the Oort cloud purely by happenstance, the convenience raises eyebrows. SWAN unfolds a contrasting tale of detection. The Solar Wind Anisotropes spacecraft, built to probe streams of solar particles, unwittingly turned into a seeker of comets when its tools for hydrogen sensing picked up the distinctive luminescence from comet halos. SWAN comets tend to materialize abruptly within the records, their hydrogen outflows signaling arrival ahead of visual scopes. This hydrogen marker reveals key details about Swan's vigor. Diverging from inert boulders that ignite only under the sun's warmth, Swan exhibited venting upon detection, having been operational for months or even years, forging the hydrogen sheath that exposed its whereabouts. For a comet said to trace an erratic path, it arrives at its solar system entrance with uncanny readiness. Stereo delivers the most riveting account of origin. Spacecraft dedicated to solar scrutiny, placed to observe our star's behaviors, glimpsed this comet plunging sunward in their side views. Stereo comets frequently turn into reckless sun skimmers, hurtling near enough to our sun to either shatter in a blaze of glory or re-emerge profoundly transformed. The schedule merits scrutiny. Stereo's inbound phase aligns with an era of intensified solar unrest, where our star's magnetic forces churn with unusual ferocity. Mere chance? Or might solar maximum foster an environment that pulls in bodies from the system's periphery? The alignment strikes as too precise to dismiss outright. Atlas K1 bears the burden of stellar anticipation and subsequent letdown. When the Asteroid Terrestrial Impact Last Alert System initially spotted this body, initial luminosity forecasts hinted at it rivaling the grandest comets of recent decades. In truth, outcomes tempered expectations. Atlas K1 will probably demand binoculars or a modest telescope for clear observation. Yet what casts doubt on Atlas K1 in this probe is its detection timing, landing it amid the cluster's chronology. Still, its path details indicate it has adhered to this route for millennia. What prompts its revelation at this moment? Why precisely now, amid a rush of 6 additional comets sharing the identical viewing slot? Atlas G3 inherits the identical scouting lineage as its K1 counterpart, identified via the same Hawaii telescope array that excels at unearthing possibly threatening entities. The Atlas survey functions akin to a stellar alert network, sweeping the observable heavens every few evenings in search of motions distinct from fixed stars. What unsettles vigilant watchers is the volume of fresh comet finds linked to Atlas efforts, not due to any shortcomings in the setup. On the contrary, Atlas embodies state-of-the-art methods for spotting asteroids and comets. But when one detection network uncovers several elements of an anomalous cluster, recurring motifs surface that call for scrutiny. Comet Lemon brings a distinct lineage distinguishes this addition to our celestial assembly. Since the 1990s, the facility known as the Catalina Sky Survey Station, situated atop Mount Lemmon in Arizona, has pursued near-Earth objects relentlessly, building up what stands as one of the fullest repositories of minor bodies within the solar system assembled to date. Findings from Lemon hold the weight of long-term meticulous monitoring and precise calculations of trajectories. Expectations for viewing Lemon stay subdued, probably visible only through binoculars under ideal conditions, yet its placement within the sequence of our swarm is exactly the element that renders it compelling. Lemon enters right in the heart of the cluster, avoiding both the forefront and the rear. It holds its spot akin to a marker, upholding alignment with an exactitude rooted in numbers that defies the odds of mere haphazard dynamics in orbits. NE8 completes our group of 7, laced with a hint of ironic history. The initiative for tracking near-Earth asteroids ceased in 2007, yet the comets it identified back in its operational phase keep showing up right on time, adhering to paths plotted far in the past. NEAT embodies the enduring impact of methodical sweeps of the heavens, evidence that steadfast watching yields rewards in due course. The aspect that elevates NE's role in our swarm to special notice lies in the gaps spanning its detection and its appearance. This comet has undergone monitoring for more than 15 years, its trajectory honed via countless measurements. Absolute clarity surrounds its route, zero chance of unexpected deviations in schedule. NEAT was destined to reach us in 2025 without fail. The puzzle centers on its companionship with 6 others. Mapping the 7 orbits onto one chronological line reveals the grouping beyond dispute. These are not entities uncovered in 2025 merely observable today. Rather, they consist of comets unearthed over varied periods by diverse programs employing varied spotting techniques, all funneling into identical brief temporal slot. The range in how they were found amplifies the wonder of their shared schedule. Emissions of hydrogen, watches on the sun, hunts for asteroids, and focused quests for comets each supplied unique fragments to this enigma. One might say the cosmos intentionally dispersed hints through assorted tracking approaches to guarantee our eventual recognition of the arrangement. Ponder the outright unlikelihood in numbers. Uncoverings of comets tend to scatter somewhat evenly over periods, with sporadic bunches topping out at 2 or 3 items at most. A set of 7 comets manifesting within a span of months marks an anomaly in stats calling for scrutiny. Still, they persist, each tracing courses computed with the accuracy afforded solely by forces of gravity. Zero allowance for mistakes, no space for loose readings. Those routes were fixed eons back, as our 7 guests initiated their extended descent into the solar system's core. The riddle that troubles every diligent watcher boils down to basics. What initiated these routes with such evident harmony? What influence, spanning immense expanses and epochs in the solar system's fringes, might have gently directed 7 separate bodies to timed convergences? We avoid claiming deliberate linkage. Instead, we record the configuration that invites probing into possible orchestration. For although every single comet adheres to unerring principles of movement, their joint actions imply a phenomenon beyond mere chance. Yet prior to assessing ties to our guest from beyond the stars, grasping why this degree of bunching alarms seasoned stargazers as truly atypical proves essential. And that demands a look at the reality of ordinary years for comets. Part 3. Why this is not normal. Step inside a standard planetarium during an average year and inquire regarding observable comets. The expert there might exhale wearily, consult their records, and describe a faint specimen needing strong optics and clear nights. Perhaps, with fortune on your side, a comet suitable for binoculars draws the attention of keen followers. The majority of years slip by absent even that. Observing comets typically involves just one faint visitor, visible without aid lighting up the heavens. Such is the everyday truth of this pursuit, marked by waiting, letdowns, and rare payoffs that demand substantial gear for true enjoyment. Everyday folks stay happily oblivious to those pale, hazy spots that thrill backyard stargazers. For the average person, these celestial wanderers appear solely in old texts and apocalyptic films. But 2025 disrupts this norm with the force of a stellar mallet. Within a short span, 7 significant comets appear. Various ones glow vividly enough for snapshots using standard cameras. A handful achieve sight through binoculars, including at least one potential showstopper viewable unaided by relaxed skywatchers. Grasping the rarity of this bunching requires delving into the stats behind comet finds and sightings. Contemporary sky sweeps have transformed how we spot far-off bodies, yet the core principles governing when these icy travelers flare up brightly stay unaltered. From Hawaii's Halia Observatory, the Panoramic Survey Telescope and Rapid Response System sweeps across the whole observable dome every couple of evenings. Arizona's Catalina Sky Survey methodically charts varied sky sections with exacting care. Up in orbit, NEOISE, an infrared scope in space, picks up thermal traces from items hidden from earthbound tools. Yearly, these efforts uncover scores of fresh comets and rocky remnants, though most stay confined to telescope views indefinitely. Just a sliver ever flares to levels drawing widespread notice. On average, a single year yields 0 to 1 that hits unaided eye levels, plus maybe 2 or 3 more reachable by dedicated hobbyists. Still, enhanced spotting tech fails to account for 2025's exceptional bounty. While these scopes locate greater totals of items, the share evolving into standout comets aligns with past trends. Superior tools expose remoter, dimmer entities. They cannot conjure vivid comets from thin air where they never were. The crucial realization lies in how seeability hinges on built-in traits beyond survey influence. What makes a comet shine stems from its scale, makeup, and solar proximity at perihelion. Long ago, eons back, cosmic tugs set these traits by steering the wanderers inward. Today's scans merely herald journeys predestined. The surge in bright sightings isn't from sharper eyes alone. It's about unearthing those destined to dazzle in 2025, no matter our tools. This nuance proves vital to our probe. Should better surveys drive the grouping, we'd anticipate echoes in prior years amid tech leaps. Rather, 2025 emerges isolated as a freakish hub of motion. Scrutinizing shine levels calls for vigilance, as press hype can inflate tame sights into letdowns for laid-back viewers. Remember, the magnitude system inverts logic. Lower figures mean greater glow. At magnitude 6, unaided sight teeters on the edge in ideal pitch-black conditions. City edge watchers often require aids for anything fainter than magnitude 4. Forecasts for comet glows brim with unreliability, since vapor release varies by material and sun warmth in unpredictable fashions. Sudden surges can hit if ices burst free explosively, or fades occur when dusty shells form barriers to outbursts. Even so, seasoned sky hunters hone sharp instincts for promising targets. Thus, when longtime experts voice astonishment over 2025's packed lineup, their astonishment. Decades of diligent monitoring of faint ordinary celestial bodies traversing vast barren expanses lend profound significance to this pursuit. The link to solar maximum introduces yet another dimension of intricacy for our exceptional anim. The Sun follows an 11-year rhythm of activity, shifting from tranquil intervals marked by sparse sunspots to vigorous eras defined by recurrent solar flares and coronal mass ejections. The year 2025 aligns precisely with solar maximum, a time when the star's magnetic field achieves utmost disorder. Solar disturbances can profoundly alter the dynamics of comet tails, generating striking disconnection phenomena and atypical tail configurations that render unassuming bodies seem far more dynamic than their inherent luminosity implies. During maximum, the intensified solar wind further boosts the ion tails of comets, possibly rendering our 7 arrivals more visually captivating than they might during solar minimum. Yet, solar dynamics do not generate comets. They merely influence their visual traits once these wanderers enter the inner solar system. These entities were destined for 2025 rendezvous, irrespective of the Sun's capricious fluctuations. While solar maximum could enhance their observational allure, it fails to account for the selection of this specific year by 7 distinct comets for their initial solar system appearances. At this juncture, the role of human cognition intervenes, muddying the waters of impartial scrutiny. Our neural wiring developed to identify configurations, including within stochastic datasets, since overlooking authentic ones might have spelled doom in primeval settings. This aptitude for spotting patterns proves advantageous across numerous scenarios, yet it may also foster illusions of significant links amid pure chance. Groupings of occurrences inevitably draw scrutiny and compel interpretation. When several uncommon incidents align in time, we reflexively hunt for route drivers instead of embracing serendipitous alignment. Such mental predisposition intensifies notably when the incidents convey hints of orchestration or intent. The assemblage of 7 comets ignites precisely this impulse toward pattern pursuit. The arrival of 7 entities in close temporal proximity strikes as excessively structured to stem from pure happenstance. Our gut-level grasp of odds resists viewing such groupings as simple flukes. Nevertheless, thorough probabilistic examination demonstrates that seeming concentrations arise routinely within genuinely haphazard spreads. Toss a coin sufficiently often, and sequences of consecutive heads or tails will emerge that seem implausible, yet prove arithmetically unavoidable. The psyche grapples with embracing these groupings as inherent outcomes of chance. For our inquiry, the core difficulty lies in distinguishing valid probabilistic outliers from those concentrations that resonate deeply with pattern-hungry minds while remaining inside standard fluctuations. Establishing quantifiable benchmarks for gauging when a configuration surpasses plausible chance proves essential. Herein lies the vital role of meticulous orbital scrutiny. Should our 7 comets exhibit faint mutual gravitational effects, comparable origin zones, or aligned disruptions surpassing chance likelihoods, grounds emerge for probing orchestrated guidance. Should their grouping embody merely the illusory formations that arise spontaneously from expansive datasets, then happenstance stands as the soundest interpretation. Standards for proof demand a suitably elevated threshold. Bold assertions demand robust validation, and positing that an agency directed 7 comets toward synchronized entries undoubtedly counts as bold. Required are identifiable markers capable of persuading doubting astronomers habituated to dismantling false linkages. Yet, as we gear up to explore conceivable drivers of such synchronization, recall that the cosmos from time to time yields authentic marvels that upend our preconceptions of natural processes. At times, the unlikely rationale proves accurate, and at others, apparent flukes conceal profound realities poised for diligent revelation. An inquiry is essential to uncover these anomalies. This cluster of comets truly exists. Their convergence feels odd, prompting urgent inquiries. Yet, what power might align these bodies over immense expanses and durations? Might the rogue wanderer from beyond our stars hold the key to unraveling this stellar enigma? Section 4. The Invisible Influence. Upon facing baffling configurations in the heavens, stargazers turn to the duo of primary forces gravity and electromagnetism. Such powers dictate nearly all motion in the void, ranging from worlds' paths around stars to the dance of ionized bits in comet streams. Should an entity be drawing these 7 icy wanderers to aligned perihelions, it would rely on one of these principles. Begin with gravity, the unchallenged director of cosmic ballets within our stellar neighborhood. Any body possessing weight bends the fabric of space-time nearby, forging the unseen framework that steers world circuits and comet paths. This pull extends infinitely, with exacting calculations enabling sky watchers to forecast heavenly happenings long into the future. However, a key drawback emerges. Gravity proves extraordinarily feeble. To yield impacts detectable over planetary gulfs, it demands colossal bulk. Our central star, through its supreme tug, molds the grand sweeps of local celestial traffic. Even gas giant Jupiter, a mere 1/10th of the Sun's heft, exerts sway over rocky remnants and comet routes via its pull. To herd 7 such visitors gravitationally toward joint approaches, a thing would require heft akin to a dominant world. This isn't about gentle prods building up across eons. Rather, it's the sort of tug that orbital analysts would spot right away in their examinations. The equations brook no mercy. The path details of a comet, its tilt, elongation, and schedule mirror the pulls it has endured on its voyage. Such marks cannot be concealed or masked. Were a hefty body guiding these 7 arrivals, its traces would stand out plainly in their path profiles. The colossal world, Jupiter, exemplifies authentic orbital guidance. That behemoth has etched voids in the rubble ring, snared clusters of Trojan rocks trailing its loop, and rerouted myriad comets via close gravitational brushes. We gauge these impacts with accuracy, compute the driving powers, and foresee upcoming clashes reliably. Such patterns provide a model for spotting covert direction. Should an unidentified bulky form have shaped this septet of comets, we'd detect uniform path disruptions, matching pull imprints, or aligned shifts indicating a unified origin. Lacking these indicators would solidly dismiss gravitational alignment. Magnetic influences present an alternate, yet similarly limited, option. These frozen relics bear electrical loads, as sunlight strips electrons from their vapor halos, and shifting ions react to field lines in observable fashions. The stellar breeze, a steady outflow of energized specks from our luminary molds, the charged appendages of comets, and triggers vivid severances amid field upheavals. Yet magnetic pulls function far unlike gravitational ones. They tweak appendages and envelopes without markedly shifting core paths. An icy body streamer may coil and vary under stellar field fluxes, yet the nucleus persists on its pull-dictated route with unyielding accuracy. The notion that field lines might direct 7 comets to joint entries confronts overwhelming barriers in natural laws. To achieve such guidance would demand field intensities vastly surpassing known levels in our system, along with the power. The demands for energy in any such scenario would vastly outstrip the output from our sun's radiation. Forces of that magnitude appear solely near neutron stars and black holes. Additionally, electromagnetic interactions create distinct markers in the spectral lines and tail formations of comets, signatures too prominent to conceal. Should intense magnetic fields be guiding these 7 intruders, observatories monitoring them would spot the unmistakable indicators right away. This leads directly to the standards that distinguish mere conjecture from genuine science. Authentic guidance, be it gravitational or electromagnetic, demands detectable traces that withstand thorough scrutiny. Essential are overlapping orbital parameters hinting at unified external factors, steady deviations surpassing instrumental precision, and aligned irregularities defying separate developmental paths. Now, let's examine these standards against our 7 comets in a methodical way. Do Pan-STARRS, SWAN, Stereo, Atlas K1, Atlas G3, LEMON, and NEAT exhibit shared orbital traits implying collective external shaping? Have their trajectories been molded by dynamics outside the solar system's routine gravitational framework? The initial assessment disappoints those favoring hidden agendas but bolsters trust in established physics. Everyone traces a path aligning with solo progression amid familiar pulls. Their origins, tilt angles, and arrival sequences reveal no signs of orchestration past the random grouping statistics might predict. Pan-STARRS sweeps in from an angle unlike SWAN's. Stereo's close solar skim shows no kinship to Atlas K1's farther arc. LEMON and NEAT sprang from varied outer solar realms and pursued markedly separate courses to their present spots. Were a concealed director synchronizing these entries, we would anticipate faint yet quantifiable links in their orbital histories, shared crossing points in their routes, matching disturbances indicating joint effects, and arrival links stretching past plausible chance. Rather, we observe 7 distinct bodies on 7 distinct trails, uniting merely by hitting maximum visibility in roughly the same window. Their paths recount lone voyages from varied launches, molded by the reliable tug of solar gravity plus sporadic planetary brushes. This doesn't rule out some outer orchestration entirely, yet it sharply elevates the proof threshold. If an unseen force is steering these comets, it works via tactics so faint they elude today's tools. The straightforward view chance bunches, amplified by better detection tech, fits the data more snugly. Yet the probe shifts to a fascinating angle with 3I Atlas as a possible orchestrator. Unlike the 7 standard comets, this outsider owes no debt to the binding orbits of solar system locals. Its hyperbolic path and alien routes position it as a true outsider in our stellar turf. Might such a wanderer, for all its slight bulk, alter the schedule or actions of homegrown comets via processes beyond our grasp? This query strains against standard physics limits, but merits deep thought amid the odd setup. 3I Atlas's shortcomings as a guide stand out at once. Its projected mass lags well behind planet-level heft, rendering pull effects trivial. Its swift solar system transit offers scant window for gradual nudges to build. Its course avoids direct overlap with any of the 7 traditional comets, yet dismissed from any notion of near misses capable of generating detectable impacts. Yet the sheer synchronicity of events continues to unsettle minds that crave a cosmos devoid of enigmatic links. An extraterrestrial wanderer showing up amid the solar system's busiest comet season in living recollection strikes many as far too neat to chalk up to mere luck. Though 3I Atlas holds no power to alter comet paths outright, might its appearance align with factors boosting the odds of such groupings? Such inquiry ventures into captivating realms of conjecture, all while staying grounded in empirical limits. We're steering clear of notions like unseen towing mechanisms or bizarre principles defying proven principles. Instead, we're pondering if an interstellar arrival could overlap with innate mechanisms amplifying comet vigor or spotting frequencies. Conceivably, 3 Atlas acts more as a signal than a trigger, like a stellar windsock signaling setups ripe for comet unveilings. Interstellar travelers might favor epochs when the solar periphery undergoes intensified tidal disruptions, hastening the inward treks of comets toward the sun. These ideas call for rigorous probing over offhand musing, yet they highlight how apparent impossibilities in alignment could arise from everyday dynamics unfolding across vast expanses we're just starting to grasp. The cosmos has caught us off guard in the past with understated ties that once appeared inconceivable. As we gear up to scrutinize our interstellar enigma more closely, keep in mind that the deepest breakthroughs frequently start with sightings that strain against standard interpretations. At times, what seems unattainable simply bides its time for superior tools and finer scrutiny to expose its essence. Part 5. Raising the Alert. The alert we're raising lacks the piercing cry of looming catastrophe. Rather, it carries the steady pitch of scholarly intrigue facing a baffling trend. Envision it as a stellar haze sensor, not a blaze klaxon. An oddity unfolds in our starry vicinity, and prudent inquiry insists we probe it thoroughly prior to any judgments. The year 2025 holds the potential for a heavenly display, converting idle skywatchers into fervent comet chasers. Several vivid bodies unfurling dazzling trains all at once, imaging chances that arise maybe once every few decades. Online platforms buzzing with sequenced clips of heavenly intruders streaking through constellations with near-orchestrated grace. The display carries zero peril in itself. Comets essentially consist of delicate entities, scattered aggregates of frozen water, grit, and carbon-based substances scarcely clinging via their feeble pull. As sun warmth reshapes them into the stunning visions that seize collective fancy, we observe them essentially disintegrating gradually, dispersing matter lost forever. Even the tightest sweeps in our 7-comet sequence stay amply remote by cosmic measures. Pan-STARRS' closest swing carries it far past lunar distance, while Swan and Stereo trace routes offering no imaginable risk to our planet or other key objects. These represent overflights, not impact trajectories. The real alert stems from the innate template-matching circuits etched into human cognition for self-preservation. When assorted anomalies bunch up, we naturally hunt for route drivers instead of shrugging off serendipitous overlap. This instinct aided our forebears in spotting unified perils amid wild settings. But today's people extend this template-hunting drive to astral occurrences, dwarfing our gut-level comprehension. We behold 7 comets converging at the same time and promptly speculate on their origin. What power might orchestrate such exactness? What prompts these celestial wanderers to traverse immense cosmic expanses at this precise moment? And what draws them in unison? Such inquiries gain even greater urgency alongside the arrival of 3I Atlas, that enigmatic wanderer from beyond our system, whose schedule feels suspiciously aligned to dismiss as mere chance. The tale unfolds effortlessly on its own. An extraterrestrial scout materializes. A cluster of comets trails in its wake. Evidently, events are unfolding that call for urgent scrutiny. Online platforms' recommendation systems boost this storyline, as enigmas and whispers of plots fuel the interaction stats powering their business models. Clips hinting at secret links among sky occurrences outpace viewership for precise breakdowns of trajectories and chance calculations. The account expands with each retelling, nourished by humanity's shared craving for purpose amid a seemingly chaotic cosmos. At this juncture, our principle of responsibility proves essential. Any daring assertion needs thorough validation via proven scientific laws and empirical records. Conjecture is permitted, indeed welcomed, yet it demands explicit tagging and adherence to fitting proof thresholds. Mere amusement cannot excuse advancing baseless ideas as proven truths. We must repeatedly highlight the gap separating display from cause and effect. Stunning need not imply orchestrated. Thrilling need not imply contrived. Striking need not imply perilous. Nature in the cosmos routinely yields wonders surpassing our sense of beauty, needing no outlandish interpretations. Reflect on the way intensified sunspot surges in 2025 will heighten the spectacle of our comet procession. The Sun's peak phase delivers repeated plasma bursts and swift charged flows that profoundly alter how comet appendages behave. Charged appendages could extend over several sky spans amid intense solar outbursts. Severance incidents might foster the appearance of comets deliberately dropping fragments. Such occurrences will spawn stunning images and footage implying joint actions by our 7 guests. Digital networks will overflow with visuals seemingly capturing aligned appendage shifts, concurrent flares in luminosity, and further oddities hinting at outside manipulation. Truth lies in simpler origins, yet equally captivating. Every comet reacts on its own to identical sun conditions, yielding seeming unity via uniform contact with ramped-up solar output. Picture observing 7 distinct wind indicators, all aligning under gale forces. Unified reaction to a universal force rather than proof of directed oversight. This alignment with the Sun's zenith introduces fresh depth to our probe. What links our atypical comet season to the height of solar vigor? Might solar rhythms tie into how often icy bodies start plunging inward from distant realms? Perhaps pulls from gravity or fields tied to solar peaks subtly shape when comets reach us. These probes venture into conjecture, yet stay anchored in observable patterns. Sun behavior adheres to thoroughly recorded rhythms linked to diverse atmospheric disturbances in space. Should solar peaks boost odds of spotting or welcoming comets, that pattern ought to emerge in records across several such rhythms. The analytical approach we're building calls for unwavering watchfulness against selective seeing, that impulse to view unclear signs as backing favored views. Upon noticing odd appendage patterns, our initial step ought to involve scanning for sun flare impacts, steering clear of far-fetched unity schemes. For sudden glow surges, we ought to probe the body's makeup and heat from the sun over presuming outside prods. For path deviations, confirm data precision and weigh familiar disruption origins prior to suggesting unseen forces. Such a methodical perspective preserves our capacity for awe and valid conjecture without stifling it. It merely aligns our intrigue with verifiable data instead of fanciful projections. The cosmos offers ample real enigmas, sparing us the need to fabricate extra riddles. This cluster of 7 comets stands as a valid outlier in statistics, warranting thorough scrutiny. These groupings happen infrequently, enough to prompt a deep probe into possible root factors. Should our examination uncover only random alignment boosted by advanced detection tools, that finding alone enriches our grasp of solar system mechanics. Yet, should we uncover true links surpassing chance probabilities, such as orbital ties, synchronized passages, or odd conduct suggesting shared drivers, then we have unearthed an insight capable of redefining solar system functions. The arrival of 3I Atlas in this atypical period introduces an unpredictable twist, elevating a mere numerical oddity to a possibly deep enigma. Extraterrestrial intruders show up roughly every 10 years, rendering their schedule truly noteworthy beyond just intriguing. We aren't asserting that 3I Atlas triggered or orchestrated the 7 comet swarm. We are simply recognizing that this overlap calls for study, not offhand rejection. Though a straight cause and effect link may be absent, the association could expose subtle ties that clarify overlooked facets of solar system actions. Our duty goes further than sidestepping bogus alerts. It includes guarding against overlooking real indicators amid our rush to dismantle baseless notions. Scientific annals brim with cases where outlandish concepts, after meticulous review and growing proof, turned out true. The trick lies in upholding fitting doubt while staying receptive to data-challenging standard views. We require strict criteria for assessing bold assertions, yet without hardening into dismissal of striking proof once it surfaces. As we gear up to scrutinize our extraterrestrial guest closely, keep in mind that greatest breakthroughs frequently stem from probes sparked by basic queries on peculiar trends. At times, the cosmos seeks to impart fresh knowledge, with the instruction sometimes masked as happenstance. The cluster has triggered its alert, and we reply using science's instruments, not fear's impulses. Any solutions ahead will arise from precise gauging and review, not guesswork or presuppositions. But initially, we must comprehend our main figure of interest, the cosmic outsider whose schedule has sparked countless queries. Part 6. The Interstellar Stranger. 3. 3I Atlas marks the third verified interstellar body to traverse our solar system, an astral drifter born near a distant sun, now executing a singular hyperbolic pass through our starry domain. Distinct from all prior items mentioned, this guest holds no native origin papers. It is utterly foreign in the purest way imaginable. This difference's importance defies exaggeration. Each comet in our 7-part group arose inside our solar system's pull, shaped from the identical ancient stuff that formed worlds and satellites 12 billion years back. 3I Atlas bears frost and grit that gathered near another sun in another star-forming cradle amid circumstances beyond our conception. Envision it like getting a note in a flask from a remote coast, save that the flask crossed not a sea, but the immense void separating star clusters. The trip probably spanned millions of. For countless years, this celestial wanderer journeyed across the almost total emptiness of the space between stars, enduring blasts of cosmic rays while slowly gathering the molecular traces of its grand odyssey. Crucially for our probe, 3I Atlas presents zero risk of impact with our planet. The path it follows glides harmlessly beyond every significant world, tracing a hyperbolic arc that will ultimately hurl it once more into the void among the stars, with no chance of coming back. It's more like a scouting foray than a hostile takeover, that is, if notions of forays and takeovers even apply to what could just be a stray fragment of primordial frost. The way 3 Atlas mimics a comet weaves extra intrigue into its tail. Even at vast removes from the sun, where chills ought to lock all ice in place, this body has formed a noticeable envelope of gas and a streaming appendage. The sun's warmth at those ranges can't possibly spark the sublimation needed for such evident cometary displays. Still, the sightings plainly reveal the hazy glow that sets lively comets apart from lifeless space rocks. This early onset of action points to either a peculiar makeup, maybe rich in ultra-sensitive substances that turn to vapor under minimal chill, or an inner warmth generating the release of gases without relying on sunlight's nudge. Each option dangles intriguing hints regarding the environment in the star realm that birthed 3I Atlas. The buzz in science circles over any such outsider arises from its singular role as a raw piece from a foreign solar setup. Each observation we gather, whether dissecting its makeup via spectra, watching its light fluctuations through imaging, or charting its exact route with positional measures, yields insights into star-building dynamics outside our own sun's domain. Yet this film zeroes in on a wholly separate puzzle. Might this cosmic outsider link in some way to the odd schedule of our 7-comet cluster? The link-up could well be mere chance, yet the potential payoff warrants thorough scrutiny over offhand rejection. Should a real tie bind 3I Atlas to our 7 standard comets, it would show up in detectable marks that hold up under strict review, schedule overlaps defying mere odds, path ties implying intent over fluke, odd traits signaling common drivers rather than solo paths. The lack of those marks would forcefully deny any bond, handing us a curious but pointless overlap. But spotting solid links would unleash deep inquiries into powers at work across vast expanses we scarcely grasp. Ponder what it means if we learn an interstellar arrival can subtly sway the actions of our system's own dwellers. That power would point to interplay methods much more nuanced and extensive than today's theories allow. It would suggest ties among star clusters that go beyond the basic pulls of gravity as we know them. Even steering clear of wild theories, the schedule overlap between 3I Atlas and our comet cluster calls for real focus. Such far-flung intruders show up seldom, maybe every 10 years or so, judging by today's spotting pace. Their drop-ins ought to scatter evenly over eras, with no ties to happenings inside our solar neighborhood. And yet, right now, one such intruder shows during what stands as our strangest comet season in ages. The odds math is simple enough. When far-flung arrivals and comet clusters stand as separate happenings, their joint timing ought to prove scarce in measure. The rarer each separate occurrence, the more that joint timing raises eyebrows. Naturally, a link-up alone never proves. Proving direct cause remains elusive, yet the odd alignment of events warrants the thorough probe we're conducting. Should the cosmos be hinting at hidden ties, linking far-off wanderers to nearby celestial bodies, we must tune in attentively to grasp the insight. Expectations surrounding the luminosity of 3I Atlas demand prudent handling to prevent future letdowns. In contrast to the dazzling prospects of our 7-comet cluster, this outsider from beyond will probably stay visible only through telescopes during its entire traverse. The value it holds for science vastly outshines its appeal to everyday skywatchers. Around the globe, experts and hobbyist stargazers are uniting in watching efforts to extract the utmost knowledge from 3I Atlas's fleeting sojourn. Each scrap of illumination captured from it carries priceless details on the environment of a distant star's domain. There's no repeat opportunity to probe this exact interloper. Its path, curving hyperbolically, guarantees a single pass with zero chance of circling back. Such watching initiatives offer our prime shot at uncovering links between 3I Atlas and the 7-comet swarm. Should common oddities appear, like matching flares and shine, linked tail formations, or schedules defying mere luck, they ought to surface via precise tracking of every one of the 8 bodies at once. The real hurdle is teasing true links apart from the false designs that arise as minds sift through tangled information streams. Our innate tools for spotting links in chaotic settings can fabricate order out of nothing, especially under pressure to uncover bonds. That's precisely why we enforce a firm divide in our work between raw sightings and their meanings. Readings of light shifts, path details, or light spectrum traits stand as unvarnished facts. Delving into possible ties among those readings shifts us to probing ideas, demanding doubt-temper eagerness. Science's approach equips us to handle this equilibrium. Number crunching lets us gauge odds that spotted links stem from pure happenstance instead of real bonds. Outside checks confirm that seeming designs hold up under review from varied teams wielding diverse gear and methods. Yet the toughest scrutiny still hinges on personal calls about what proof suffices for bold assertions. Claiming a spacefarer sways the actions of inter-system icy bodies ranks as wildly bold, calling for equally robust backing before earning real weight. As we gear up to scrutinize 3I Atlas's path features and forecast actions, keep in mind the probe's implications reach well past untangling a quirky overlap. Should true bonds link such spacefarers to the rhythms of our home system's workings, that find would upend our grasp of how star clusters mingle over immense voids. Reality might weave tighter webs than models predict, with faint forces at play on vastnesses beyond gut feel. Alternatively, it could just toss us a quirky data quirk to hone our skill at sorting signal from noise. Regardless, the truth hides in the records, and the moment has come to inspect our cosmic intruder up close. The outsider is here, its tail etched in the curves of its inbound path. Part 7. Orbit of Intrigue. The trajectory of 3IA Atlas reads like a cosmic passport documenting a journey that began in interstellar space and will end. In contrast to the closed elliptical paths that bind planets and conventional comets into perpetual loops encircling the Sun, this interloper traces a hyperbolic trajectory, signaling mathematically an entity possessing sufficient speed to break free permanently from the Sun's gravitational hold. Envision a whip-like path plunging from vast cosmic voids toward our central star, arcing tightly around it before surging onward into the void between stars. Expect no comebacks, no further windows for study. 3I Atlas claims just a single transit across our cosmic locale, and we are observing the event unfold live. Details of its orbit weave a captivating tale of beginnings and endpoints. The intruder hails from a bearing aligning broadly with the Perseus constellation. While the emptiness of interstellar realms offers no markers to pinpoint its exact launch site, the surplus hyperbolic speed, its residual pace post-solar gravitational release, implies a voyage enduring hundreds of thousands of years from the closest plausible stellar neighbors. The aspect that renders this course especially captivating lies in its tilt compared to the ecliptic, that planar expanse housing planetary tracks and the bulk of solar system rubble. 3I Atlas enters at a gentle slant, avoiding a steep dive from far overhead or underneath the plane of worlds. Such near-flat alignment positions the body near the routes frequented by members of our 7-comet cluster. Scrutiny of this tilt is essential as it shapes the odds of gravitational tugs with denizens of our system. An arrival from elevated galactic heights would skim our setup with scant chance to stir native motions. Yet 3I Atlas's tempered angle sustains its presence near planetary and cometary paths over a prolonged span. Close brushes are not implied here. Gaps remain vast, reckoned in astronomical units well outside zones of tangible pull. Still, it signals that 3I Atlas lingers for months in the broad spatial zone where our 7 standard comets conduct their sunward ventures. The backward slant of 3I Atlas's path introduces further intricacy in its layout. Whereas typical solar system bodies circle the sun matching the spin of worlds, this outsider barrels in counter to that flow. Such opposition generates approach speeds surpassing those in routine solar system brushes. Swift differentials generally dampen pulls, since rapid passers zip past influence spheres in brief flickers. Should 3I Atlas be nudging comet paths in some fashion, its reverse heading would counter that by shortening any would-be overlap. Such path traits set key limits on our probe. Whatever sway 3I Atlas could hold over the 7-comet group demands processes bypassing near misses or drawn-out pulls. Standard orbital herding via classic sky mechanics grows ever more improbable under geometric scrutiny. Yet layout by itself fails to rule out every link. Alignments in schedule between 3I Atlas's pivotal path milestones and odd shifts in our 7-comet ensemble might uncover forces beyond basic pull math. Ponder the import of crossing points, where 3I Atlas's route intersects the ecliptic. These junctures mark instants of nearest proximity to zones held by standard comets and their trailing dust streams. Should ties exist between the outsider, when interactions between the interstellar intruder and nearby solar system bodies take place, such encounters at the ascending and descending nodes offer prime chances for notable effects. The positions where 3I Atlas crosses the ecliptic plane happen on precisely determined dates, computable through exact celestial mechanics. Should these timings align with odd happenings among our cluster of 7 comets-like surges in luminosity, irregularities in tails, or shifts in paths, such alignments would signal real links between them. Defining odd happenings proves tricky amid the inherent wild swings and caprice in comet actions. Routine swings in shine, formation of tails, and slight path adjustments arise as these icy wanderers react to the sun's warmth and the release of gases. Standards for proof need raising to filter out everyday comet antics. Tools from Stats help tackle this issue without prejudice. By keeping a steady watch on our 7 classic comets and logging every case of shine shifts, tail occurrences, or striking traits, we could check if these incidents bunch up near 3 Atlas's main path markers more often than mere luck suggests. The baseline idea that 3I Atlas bears no tie to the 7-comet group expects quirky incidents to scatter evenly over time, with no link to the outsider's path highlights. Notable breaks from even spread would hint at ties, whatever the cause might be. Yet caution against cherry-picking looms large. Humans often spotlight seeming matches while overlooking times when anticipated links don't show. Solid probing demands logging every possible tied event beyond just those fitting favored views. The path changes of 3I Atlas open further windows for probing possible bonds. Nearing its closest solar point, the sun's heat ought to spur fiercer gas releases, possibly sparking matching reactions in fellow bodies if any signaling or syncing system operates. Forecasts for 3I Atlas's light pattern reveal gradual intensification heading sunward, may be broken by sharp flares if ices turn to vapor fast or if inner parts break apart from heat strain. All such happenings unfold at foreseen moments and spots on the route. Should the 7-comet group react to 3I Atlas's doings, their replies ought to match the outsider's foreseen light spikes in timing, Closer the time match, firmer the case for true bonds over pure chance overlaps. Still, we can't rule out fake links from joint reactions to shared outer forces instead of straight body-to-body chats. Sunstorms, swings in the magnetic fields between planets, or varied space weather could hit every comet at once, mimicking teamwork sans any direct object talks. This sun-driven idea foresees any synced acts tracing back to clear space weather triggers, like sunbursts, ejections of crown material, or swift particle flows that tweak comet gases in trackable fashion. Spotting those sunsparks would tip scales from odd syncing setups toward standard star physics workings. The path traits of 3IA Atlas likewise limit how long any sway over system locals might last. Its hyperbolic route guarantees a short stay in our cosmic turf, roughly 18 months from first spot to last view as it slips past detection range. This brief window, the brief encounter duration, implies that any impacts on the cluster of 7 comets need to emerge swiftly and be observable using today's equipment. Gradual effects building up across decades or centuries would stay undetected amid 3I Atlas's short stay. While delving into the detailed forecasts for the perihelion transit, keep in mind that the rules of orbital dynamics function with unerring accuracy, no matter the unusual scenarios under scrutiny. 3I Atlas is set to hit its nearest point to the Sun at a spot and moment shaped solely by gravity's pull, indifferent to our guesses about extraterrestrial sinking or signals from distant stars. Facts and spatial patterns speak clearly on their own, yet if those patterns link back to our 7-comet swarm is still unresolved, with perihelion potentially delivering the verdict. Part 8. What unfolds during perihelion? For every comet, perihelion stands as the pivotal instant. It's the Sun's nearest draw, where a slow buildup over months or years surges into a burst of frenzy. With 3I Atlas, this turning point holds extra weight as it signals when a wanderer from beyond our system faces the raw force of our star's rays and ejected particles. The dynamics at perihelion blend foreseeability with spectacle. As 3I Atlas nears the Sun's rays grow fiercer, following the inverse square law, with illumination and warmth doubling every halving of the gap. The frost that stayed solid through the vast space voyage starts to turn to gas, forming a shroud of vapor and particles that shifts a shadowy, lifeless core into a radiant, dynamic comet. Yet the makeup of ice from interstellar voids probably strays from the water-heavy blends typical of our system's icy bodies. 3I Atlas took shape in the chilly outskirts of some foreign star setup, where chill levels in reactive settings could have boosted alternate molecular types. Dominance might go to carbon monoxide, carbon dioxide, methane, alongside stranger substances. Such variances in build ought to show up via spectral scanning as it passes perihelion. Vaporized and stirred by sunlight, every molecular kind emits distinct spectral signatures. 3I Atlas's light profile will act like a preserved signature of its origin locale, carried intact over eons of cosmic drifting. Should our probe reveal true ties between 3I Atlas and the 7-comet swarm, the perihelion phase offers prime chances for striking disclosures. The fierce solar warmth fueling maximum comet vigor could likewise spark any processes linking actions across several bodies. The signs to monitor mix faint hints with bold displays. Abrupt spikes in luminosity frequently signal the release of highly fickle substances or the bearing of new icy layers as outer dust shells wear thin. Such flares might ramp up a comet's glow by 10 times or beyond in mere hours, yielding dazzling views and hints into hidden makeup and build. Streams of matter erupting from targeted spots on 3I Atlas's core might generate uneven push that nudges its path off course a bit. Well recorded in usual comets, these gravity-defying pushes would, in an outsider like this, yield fresh knowledge on how stuff from alien systems reacts to our sun's pull. Special focus goes to how 3I Atlas's tails evolve, since they give a live glimpse into interstellar stuff clashing with the solar breeze. Ion tails arise as the sun's UV light charges up the comet's vapors, spawning ions that flow driven by the sun's magnetic influence. The ion tail drifts away from the central body. Examining this tail's extent, alignment, and reactions to shifts in the solar wind will uncover interactions between gases originating from a distant star system and the stream of particles emanating from our own sun. Deviations from the norms seen in typical comet appendages could signal unique makeup that sets apart substances from beyond our solar system versus those native to it. In contrast, dust tails obey distinct principles molded by the push of radiant energy instead of electromagnetic pulls. Factors like the dimensions, spread, and makeup of these dust grains dictate the extent to which sunlight's rays can shove them off straight-line courses. Bigger chunks stay close to their initial roots with minimal diversion, whereas tiny specks get swept into broad arcing appendages spanning wide swaths of the heavens. Should 3I Atlas unleash an exceptionally striking dust tail, such a display could point to an abundance of small grains highly susceptible to the outward force of solar radiation. On the other hand, breaking up as it nears the sun might abruptly unleash vast amounts of dust long trapped inside the comet's core framework. Such breakups mark the most intense consequences of skimming closest to the sun. When intense solar warmth, spinning tensions, and buildup from sublimating ices overwhelm the fragile hold of gravity, the comet can shatter, often dividing into several pieces that drift apart while tracing the orbit. For 3I Atlas, any such splitting holds special weight, as it would expose inner substances untouched since the object's birth amid another star's domain. The newly bared exteriors from this rupture would grant rare chances to probe pure interstellar stuff through spectrum studies. Yet this same splitting might muddle efforts to probe links to the 7 comet swarm. Pieces veering on marginally varied paths could mimic synchronized actions that aren't really there, merely due to the tricky angles of following multiple linked bodies at once. During 3I Atlas's closest solar approach, the surrounding solar wind setup introduces yet another factor that might sway both the outsider comet and any ties to fellow wanderers. At peak solar activity, denser particle flows, intensified magnetic zones, and bursts of ejected crown material can profoundly alter how comet tails behave. These cosmic weather patterns spawn dazzling sights in the sky. Disruptions like tail severings, turbulent plasmas, and field realignments can cause appendages to seem to coil, buckle, or snap off completely. Though these happenings unfold separately near each comet, they all react to identical solar prompts, which might foster illusions of teamwork without true linkage. Unraveling real teamwork from mere echoes of solar influences hinges on exact moments, sharp details, and spatial breakdowns. Ripples in the solar wind spread from the sun at steady speeds, hitting various comet spots at foreseeable intervals. Should odd actions among our 7 comet swarm line up with 3I Atlas occurrences, yet defy explanations from these wind travel lags, such alignment gains real intrigue. Around the globe, hobbyist stargazers gear up for watch parties to track 3I Atlas right through its sun-grazing phase, delivering widespread views beyond any lone telescope's reach. This grassroots effort in science will yield steady brightness records, image logs of tail evolution, and instant notices for sudden flares or splits. The watching efforts also reach out to expert installations. Utilizing orbital platforms, earthbound viewing stations, and dedicated programs for spotting comets, we are assembling the fullest examination yet of an object from beyond our solar boundaries. Each captured ray of illumination carries priceless insights into the environment of a distant star's domain. However, the probe demands simultaneous scrutiny of the entire group of 7 established comets over this time frame, seeking out odd patterns in their actions that could link to occurrences involving 3I Atlas. Such a side-by-side method aids in separating routine fluctuations in comets from possible meaningful links that go beyond mere chance. Spotting these faint ties demands accuracy that stretches today's watching tools to the edge. Tiny shifts in luminosity, small imbalances in tails, or minor deviations in paths could offer the sole clues to unusual influences working just out of reach of standard sensing techniques. With the closest solar pass nearing, keep in mind that cosmic rules follow unchanging principles, no matter our desires for thrilling finds. 3. Atlas will glow brighter, grow appendages, and perhaps break apart due to its own makeup reacting to the sun's warmth, rather than any plan to deliver awe-inspiring sights to earthly watchers. Still, amid these everyday mechanisms, hide chances for deep insights into the essence of matter from other stars and how it acts amid our sun's influence. If such insights reveal ties to the cluster of 7 comets, it's a matter yet unresolved, resolvable solely through meticulous watching. The grand machinery of the heavens keeps turning with exact rhythm, unmoved by guesses, yet reliable in yielding the information required to tell apart mere dreams from true breakthroughs. Part 9. The Swarm and the Sun. The sun follows rhythms that outlast human focus, switching from stretches of quiet to bursts of intense action like a steady beat from the stars. This 11-year pattern driving such shifts climbs to its height in 2025, turning our central star into a fiercer, more eye-catching form than its typical state. Solar maximum delivers a surge of sunspots, the shadowy spots signaling areas where powerful magnetic forces pierce the sun's outer layer. These hubs of magnetism hold vast reserves of power, which now and then burst forth violently, flinging ionized bits and waves of energy outward at velocities that span the solar realm in mere hours or days, all relevant to our probe of the 7 comets. This ramped-up solar vigor offers both advantages and hurdles. Greater concentrations of particles and intensified magnetic zones during solar maximum can greatly heighten the display of comet tails, rendering ordinary bodies far more striking than in lulls of solar quiet. Imagine the clash between a coronal mass ejection, a massive million-ton orb of charged gas blasted from the sun's outer atmosphere, and the fragile charged tail of a comet. The resulting pressure front and field twists can squeeze, bend, or outright detach the tail across events lasting hours, yielding some of the most striking images of comets imaginable. Such separations in tails happen amid swift flips in the solar wind's magnetic polarity that the comet's current tail setup can't handle. The discarded tail floats off as cosmic junk as a fresh one starts shaping in the altered field setup. For those not versed in the dynamics of space storms, these happenings might seem otherworldly. Suddenly, a comet's tail could show bends, tangles, or twisting forms that challenge the basic idea of vapor flowing straight from a core. The tail might seem to comet tails can snap apart completely, fostering the deceptive notion that an external force has struck or impaired the icy wanderer. Yet, in truth, such striking displays signify routine reactions to atypical conditions near the sun. The core of the comet stays intact and unharmed. Merely its delicate sheath of charged particles reacts to shifts in the surrounding magnetic fields. Nevertheless, the spectacle proves so striking that watchers naturally pursue outlandish theories, instead of recognizing standard solar weather patterns as the source. This interplay with the sun holds special significance for our analysis, given that every one of the 8 entities under examination, comprising 7 classic comets alongside 3I Atlas encounters identical space weather dynamics. Each endures the identical outbursts from the sun's corona, the identical rushes of swift particles, and the identical fluctuations in magnetic forces typical of peak solar phases. Should vivid disruptions in tails happen at the same time among several comets, the simplest rationale points to collective reactions to unified solar prompts, not some enigmatic interplay among the bodies. One massive outburst from the sun might alter tails across the inner solar realm, generating a false sense of harmony unrelated to any interplay or signaling between comets. The intensified solar outbursts in 2025 likewise impact Earth's protective magnetic shield, heightening the sense of spectacle surrounding this exceptional year of comets. Storms in the magnetic field, sparked by incoming solar particles, have the power to scramble satellite signals, hinder GPS guidance, and in severe instances, endanger power networks. In planar sight, such events drive the glowing auroras equatorward, enabling people in temperate zones to behold the shimmering displays usually confined to high-latitude areas. The pairing of vibrant comets with vivid auroras crafts a celestial performance that seems eerily otherworldly in its vigor and coincidence. Essential, though, is distinguishing true causation from mere alignment in these links. Solar eruptions influence both comet tails and Earth's magnetic envelope, yet comets exert no control over magnetic upheavals here. The Sun propels these occurrences separately, yielding overlapping timings in their manifestations without suggesting any direct tie between comets and effects on our planet. Such clarity proves essential in assessing assertions of ties between 3I Atlas and diverse earthly events. Should orbital networks glitch or energy supplies falter amid the path of this far-flung interloper, solar dynamics offer a much sounder basis than any arcane sway from a tiny remote comet. The alignment of solar peak with this odd comet season sparks compelling inquiries into possible links between sun cycles and the detection or inbound timing of comets. Does ramped-up solar vigor perhaps alter how often comets embark on their sunward paths from distant orbits? Could pulls from gravity or electromagnetism tied to solar highs shift when comets reach us? Such probes edge into conjecture, yet anchor in observable realities. Solar vigor adheres to thoroughly recorded rhythms that ought to imprint clear traces in records of comet approaches if real links hold. Archives covering various solar loops might uncover if lively sun eras align with boosted comet presence beyond mere coincidence. Our probe demands precise disentangling of sun-driven outcomes from any conceivable bonds between 3I Atlas and the cluster of 7 comets. Upon spotting odd tail antics, our initial step must check solar watch networks for crown ejections, rapid wind blasts from the sun, or additional verified solar catalysts. Merely once we've factored in established solar roles, can we fairly entertain stranger rationales, for careful examination of documented occurrences forms the foundation of this systematic strategy, which guards against hasty judgments born from dismissing standard explanations in pursuit of dramatic outliers. Advanced networks for tracking space weather deliver instantaneous insights into sun-driven processes, enabling exact alignments between these dynamics and the patterns seen in comets. Instruments like the Solar and Heliospheric Observatory, the Solar Dynamics Observatory, alongside terrestrial arrays of magnetometers, relentlessly monitor stellar states and their spread across the void between planets. Such robust setups empower us with remarkable precision to separate comet actions propelled by the Sun from truly odd happenings that could signal external factors. Should 3I Atlas in any way alter how classic comets act, such impacts ought to stand out clearly amid the usual fluctuations of solar rhythms. Enthusiast watchers supply vital surveillance tools that bolster the work of expert space weather outfits. Global teams of comet imagers capture shifts in tails, fluctuations in luminosity, and alterations in form with a level of timing detail that frequently surpasses the output from overburdened institutional telescopes. This widespread array of eyes ensures unbroken vigilance over all our celestial wanderers, generating thorough archives ripe for in-depth matching of sun events to comet responses. A fuller archive of sightings lets us more assuredly pinpoint truly exceptional incidents deserving deeper scrutiny. The ramped-up solar vigor expected in 2025 ensures our probe into comets will play out amid a flurry of space weather incidents. Such a lively stellar backdrop promises abundant chances for stunning captures of comets, even as it muddies the waters in spotting faint forces that could function apart from sun-sparked triggers. The core difficulty rests in upholding solid benchmarks for proof while staying receptive to real oddities that could uncover fresh facets of how comets move. The cosmos has caught us off guard in the past with delicate links that once appeared inconceivable, and the peak solar phase may furnish the vital energy to spot faint interplay signals. As we gear up to explore space weather's toll on terrestrial settings, keep in mind that our stars' patterns chiefly fuel the vivid displays tied to lively comet eras. The issue at hand avoids debating if sun activity shapes comet actions, that bond stands firm, but probes if extra forces join the solar ones in manners beyond existing models, as the stellar ballet persists, directed by flux lines and flux of charged bits linking our central fire to all within its pull. Yet amid this known routine, fresh moves could linger, ready for unveiling. Part 10. Echoes on Earth. Space weather's reach to our world weaves an intricate tangle of tech frailties that escape most minds until breakdowns hit without warning. Comets offer no immediate peril to Earth, yet the intensified sun output lending comets their dazzling displays can unleash chaos on the digital backbone sustaining today's society. Ground-based magnetic upheavals, Earth's reaction to incoming solar blasts, spark voltages in grid cables, risking transformer burnout and chain reaction outages. The March 1989 event that toppled Quebec's power network illustrated vividly how celestial turbulence morphs into grounded woes affecting vast populations. Orbiting platforms endure raw hits from solar flux assaults, swift protons and electrons, boosted by flare outbursts, breach vessel armor, sparking brief glitches, or delicate circuits in high-tech devices, can suffer irreversible harm. During heightened bursts of solar output, systems for global positioning, orbital messaging, and atmospheric forecasting lose their dependability. Aerial transport introduces further risks, especially on routes crossing the poles, where the planet's magnetic shield offers minimal defense against incoming cosmic rays. Carriers commonly divert routes amid fierce magnetic tempests to shield travelers and staff from heightened radiation exposure, all while safeguarding onboard gear from atmospheric disturbances originating in space. Such disruptions foster a tricky mental backdrop for assessing assertions linking sky occurrences to ground-based issues. As comet surges align with peak solar phases, the alignment appears suspiciously perfect to dismiss as random. Blackouts in electricity, breakdowns in signaling, and glitches in guidance strike as signs of otherworldly meddling from that peculiar cluster of 7 comets. In truth, things are far more ordinary, yet no less captivating. Sun-driven tempests influence comet patterns and planetary tech alike via entirely separate pathways. Comets react to denser streams of particles and shifts in cosmic magnetic fields. Planetary setups react to identical particle flows upon their clash with our world's magnetosphere. The link stems from a shared origin in solar dynamics rather than any comet-driven sway over earthly operations. Such a separation proves vital as 3ILAS enters the discussion. Should orbital networks falter or electrical networks buckle amid the interstellar traveler's approach, sun-driven forces offer a much sounder rationale than any straight impact from a tiny far-off comet. One must push back against the urge to tie striking coincidences to bizarre origins, opting instead for proven laws of physics. Official bodies tasked with tracking space weather have built advanced alert networks that follow solar eruptions from their birth in flares across vast expanses between worlds, right up to their strike on Earth's magnetosphere. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center releases predictions and alerts with the intensity reserved for earthly extreme weather crises. These observation setups enable exact matching of recorded space weather incidents to any tech glitches that align with odd comet surges. Whenever system breakdowns hit amid confirmed magnetic upheavals, sun origins emerge as vastly more probable than enigmatic comet forces. The ramped-up solar vigor in 2025 ensures plenty of moments for these alignments. Peak solar eras trigger magnetic storms a few times monthly, yielding many windows for accidental overlaps between system woes and comet sightings. On average, certain links will arise just from luck, irrespective of true cause and effect ties. Hobbyists in radio transmission serve as extra watch points, frequently spotting space weather ripples ahead of formal alerts. Signal travel via the planet's upper atmosphere shifts wildly in magnetic storms, spawning signal voids or odd bounce behaviors that seasoned users spot at once. This widespread detection web delivers instant insights into space weather states, aiding in separating sun-fueled happenings from possible oddities, hinting at alternative factors. Should 3I Atlas in some way alter Earth's electric-magnetic surroundings, such alterations ought to show up across various standalone watch systems. The probing approach demands ongoing watchfulness to counter the misjudgments and blame that emerge. Simultaneous occurrences of several striking incidents often mislead the human mind. Our innate tendency leans toward attributing reasons to mere alignments in time, especially whenever the synchronization feels deliberate or significant. The rarer each separate happening, the more persuasive their joint appearance becomes. Yet, rigorous probability studies show that such seeming groupings pop up consistently within purely chance-based patterns. Keep tossing a coin over time, and certain streaks will emerge that look improbable, yet prove unavoidable by math. This very logic extends to links among solar disturbances, comet movements, and breakdowns in tech. The key difficulty involves crafting impartial standards to separate true links from the random bunches that arise in intricate setups. That demands setting normal benchmarks for how often diverse happenings might align just by luck, followed by checking real links against those chance-based forecasts. Experts in solar forecasting have devised advanced methods to tackle these issues. Techniques like overlaid time series reviews, linkage metrics, and further probabilistic approaches measure the robustness of ties among varied incidents, all while adjusting for the pitfalls of examining numerous possible links at once. Such evaluative approaches offer structures for assessing assertions regarding ties between 3i Atlas and earthly occurrences, steering clear of the instinctual hunt for designs that renders chance meetings seem profound when they're not. Proof thresholds need to stay suitably elevated to sidestep unwarranted alerts, yet perceptive enough to spot real indicators should they appear. The worldwide reach of today's tech networks opens up plenty of chances for illusory ties between sky happenings and operational glitches. Amid hordes of orbiting craft, vast arrays of gadgets, and endless signal pathways running non-stop, daily mishaps happen for no reason other than randomness. In eras of intense comet presence or odd sun patterns, these everyday slips draw extra scrutiny and potential wrong blame. An electrical blackout typically chalked up to worn gear or upkeep issues could get pinned on strange comet forces if it hits amid rising cosmic curiosity. Instruction and straightforward messaging turn vital for curbing such misplaced fault. Greater awareness of the actual ways solar conditions impact ground-based setups reduces the pull toward odd rationales for things that standard science covers well. This learning aspect carries over to our probe into possible bonds between 3i Atlas and the 7 Comet Swarm. Through keeping firm divides between proven links of action and reaction versus tentative ideas, we might delve into unusual notions absent the risk of touting baseless views as settled truths. The advanced tech of our era brings both prospects and hurdles in spotting faint effects that lurk under typical solar impact levels. Heightened attunement to electric fields could enable picking up faint traces beyond what past eras could register. Still, it heightens risks of bogus links and wrongly assigned origins. As we gear up to explore the ways mental habits and societal tales mold our views of sky spectacles, bear in mind the cosmos runs on unchanging rules of nature, untouched by wishes for thrilling finds. Planetary reactions to solar variances adhere to familiar processes, needing no unusual even amid eras of exceptional comet occurrences. The lingering impacts of solar flares ripple across our tech infrastructures in foreseeable ways that experts can quantify, scrutinize, and trace back to their authentic origins. Yet, amid the clutter of routine cosmic weather fluctuations, faint indicators could linger undetected until gear precise enough separates mere associations from true causes. Our probe persists, rooted in proven scientific principles, yet watchful for prospects that could upend our grasp of interactions between sky-based and earthbound occurrences over immense distances and durations. Part 11. Harbingers of Change. Across the span of humankind's past, vivid comets have acted as heavenly heralds, with societies reading them through lenses of profound dreads and grandest hopes. The emergence of several comets at once stirs mental frameworks that have shaped people's actions across thousands of years, turning factual stellar happenings into personal tales of destiny, shifts, and universal import. Scholars from ancient China kept detailed logs of comet sightings, tying sky phenomena to shifts in ruling houses, earthly calamities, and societal turmoils. Accounts from the Han Dynasty portray comets as sweeping broom stars that clear out outdated regimes to pave paths for fresh beginnings, an image that uncovers how societies have long pursued purpose in the rhythm of the stars. Scribes in medieval Europe viewed comet showings as godly alerts to looming catastrophes or pivotal shifts. The Grand Comet of 1066, emerging just prior to the Norman takeover of England, etched itself indelibly to the collapse of Saxon authority and the reshaping of English life. Debate lingers on whether the comet truly swayed outcomes or merely offered handy icons, yet that linkage carved a lasting niche in the annals of history. The 1758 comeback of Hal's Comet aligned with the 7 Years' War, a worldwide clash that redrew power lines over 3 landmasses. Settlers in colonial America regarded the comet as a portent of freedom from British dominance, whereas scholars in Europe hailed it as proof of Newton's ideas on gravity. Identical sky spectacles backed utterly varied tales based on societal backdrops and ambitions in governance. Such past instances show how people's thoughts instinctively weave bunches of odd happenings into unified accounts that seem deeper than mere chance. As assorted intense occurrences unfold together, be they comets, conflicts, epidemics, or civic disruptions, folks naturally hunt for hidden ties instead of embracing separate triggers. This drive to spot designs grows especially sharp amid times of communal strain or doubt. As groups eagerly hunt for clues to paths ahead, the 2025 Comet Swarm emerges in a time of swift tech advances, worries over weather patterns, and strains in global politics, laying rich soil for seeing sky signs as forerunners of upheaval. Today's media networks heighten these timeless mental habits via tools that would leave old-world scribes in awe. Algorithms on social platforms favor captivating material above true details, making sure vivid comet clips and wild ideas circulate quicker than precise star science breakdowns. Those brain roots that formerly aided in spotting real designs amid wild surroundings now react to online lures crafted to seize and retain focus. Tools for video crafting. Let hobbyist makers craft gripping tales that blend actual comet visuals with hinting tunes, intense voiceovers, and chosen sight tricks. Such works can match expert quality even as they push forward ideas. Such claims would fail rigorous scrutiny from experts in academic publications. The widespread accessibility of online tools empowers virtually anyone connected to the web to shape ongoing tales surrounding astronomical occurrences. Independent producers frequently align on parallel viewpoints without any deliberate collaboration, fostering an illusion of broad agreement on concepts that may rest on shaky empirical grounds. This collective fabrication of stories swiftly escalates basic sightings, like the influx of 7 comets in 2025, into intricate tales of universal importance, extraterrestrial encounters, or looming catastrophe. With every recounting, fresh elements, links, and viewpoints emerge, steadily veering away from confirmed realities into unbridled conjecture. Introducing 3i Atlas into this storytelling milieu offers exceptionally rich soil for imaginative spins. The arrival of an extrasolar entity amid our most atypical year of cometary activity delivers precisely the sort of enigmatic synchronization that our minds perceive as intentional instead of fortuitous. The tale essentially composes on its own. Extraterrestrial device synchronizes with the comet cluster to convey a signal or alert to our planet. Such a storyline fulfills various mental cravings all at once. It offers rationale for the odd chronology, imbues seemingly haphazard happenings with intent, and casts earthly watchers as key figures in epical cosmic happenings. Establish stargazing encounters growing difficulties in vying for audience engagement against these captivating accounts. Detailed accounts of celestial paths and chance calculations pale in comparison to the heartfelt draw of yarns that elevate simple viewers to active roles in interstellar spectacles. Forthright depictions of research ambiguities, framed as arrays of potential outcomes instead of firm verdicts, come across as less commanding than bold declarations of concealed intents. Upholding truthfulness amid these conditions demands unwavering watchfulness to resist the urge to hype research outcomes or downplay real ambiguities. By noting that certain links surpass chance thresholds, yet stressing that association falls short of establishing cause, we hazard diverting public focus toward outlets promising clearer resolutions. Nevertheless, this hurdle also unlocks avenues for scholarly instruction that standard celestial communication seldom attains. The intense societal curiosity regarding our probe into the 7 comets generates prime instances for imparting lessons on formulating testable ideas, evaluating data patterns, and differentiating raw proofs from subjective readings. Through upholding a clear divide between proven truths and hypothetical ventures, we exemplify methodical inquiry, even as we delve into notions that challenge established limits. Our inquiry evolves into a practical lesson in analytical reasoning, illustrating that bold assertions demand robust backing without rejecting odd sightings merely for appearing unlikely. The societal perspective coloring how individuals process our discoveries will unavoidably mold their judgments, irrespective of the proofs we supply. Those eager for validation of otherworldly contact will see unclear findings as bolstering their favored hypotheses. Doubters wedded to standard accounts will reject robust patterns as insufficient validation for unconventional processes. This divide mirrors profound inquiries into the foundations of knowing. The ways in which we determine credible information and adequate support for embracing atypical propositions. Varied groups enforce distinct criteria drawn from their backgrounds, expertise, and beliefs concerning existence itself. Methodical inquiry calls for tentative endorsement of outcomes grounded in current proofs, all while staying receptive to updates as fresh information arises. Such modesty of intellect might seem feeble next to the bold assurance defining fervent devotees and staunch doubters alike. Nevertheless, this adaptability stands as the paramount asset of science in separating authentic breakthroughs from mere hopeful delusions. Astronomy's past is rife with cases where seemingly absurd notions gained validation via mounting proof, alongside persuasive concepts that crumbled under scrutiny from sharper data. In probing links among 3, iAtlas, and the 7 comet swarm, our inquiry has to steer through these societal and mental tides without succumbing to their pull. Proof will reveal its own truth, provided we uphold fitting criteria for analysis and stay attuned to hints that could upend standard views. Before delving into the wildest elements of societal conjecture surrounding our comet probe, keep in mind that people's captivation with stellar enigmas mirrors a valid awe regarding humanity's cosmic role. The real test is directing that awe at inquiries resolvable via meticulous scrutiny and evaluation. Those early interpreters who discerned portents in comet lore held some truth. Heavenly occurrences indeed yield insights into vast mechanisms influencing earthly societies, yet these ties function via natural laws, not sorcery, and grasping them calls for instruments sharper than gut feelings or yarns. The forerunners are here, bearing tidings inscribed in the shared dialect of path dynamics and light analysis. Yet prior to that, we must unravel the vivid mortal glosses that always cloak such enigmatic arrivals. Part 12. The Alien Hypothesis. The boldest take on our 7 comet swarm takes guts to state outright. 3. iAtlas serves as a crafted scout from some distant society, with the usual comets forming an organized armada answering its coming. This notion leaps well past standard stargazing into conjecture realms, craving exceptional backing. Still, its consequences run so deep that rejecting it sans probe would prove just as unrigorous. Consider how a true manufactured source might manifest via proven natural laws, not pulp visions. A built entity journeying amid star realms must tackle hurdles taxing today's tech. Drive for vast voids between worlds, steering with exactness over eons and signaling over vast light-year gaps. The power needs by themselves boggle the mind. Boosting a modest scout to paces fit for star-hopping calls for energy wells, vastly outpacing what we wield now. Nuclear burst drives, matter-opposite reactors, or novel forces beyond our ken would prove essential to hit paces hauling items across star realms in sensible spans. Steering throws up matching hurdles. 3. Ia Atlas's path shows stunning exactness in aiming at our star realm from starting spots maybe hundreds of light years off. That fineness demands thorough grasp of star layouts and shifts over vast epochs, implying watching skills and reckoning power way past ours. Yet these tech feats, though striking, stay within familiar natural bounds. Evolved societies could plausibly craft means to crack star-crossing puzzles by raw wielding of laws we grasp yet can't enact. The issue isn't if such scouts hold conceptual viability, but whether 3i Atlas exhibits distinguishing between manufactured and organic entities hinges on key attributes revealed through careful examination. Spectral examination stands as our primary method for identifying engineered makeup. Natural icy bodies exhibit glowing spectral bands tied to frozen water, carbon-based substances, and basic elements that arise easily in the chilly fringes of star systems. Engineered devices could incorporate processed substances, purified elements, unusual metal mixtures, or lab-created chemicals absent from the settings where such icy bodies originate. A thorough spectral breakdown of 3i Atlas ought to indicate if its makeup aligns with typical organic icy body components or bears traces pointing to deliberate fabrication. Spotting unmistakable signs of produced materials would offer strong proof of intentional design, whereas entirely organic readings would firmly counter ideas of engineered beginnings. Scrutinizing motion patterns provides yet another path to uncover signs of human-like intervention. Organic icy wanderers adhere to paths shaped solely by gravity's pull, along with sporadic vapor releases that yield minor but noticeable propulsion. Engineered craft could exhibit path adjustments, orientation shifts, or deliberate movements signaling guided operation instead of mere reaction to surrounding influences. The path parameters of 3i Atlas reveal no signs of forces beyond gravity aside from those explainable by routine vapor ejection. Its route aligns with that of an inert body obeying natural laws over crafted intent. Still, faint guiding actions could lurk beneath our present observation limits. Especially if crafted to imitate organic icy wanderer actions, signs of outreach form the clearest indicator of deliberate creation. Active devices would probably link back to their makers via radio waves, light bursts, or various energy emissions pickable up by ground-based listening arrays. Experts in seeking distant minds have established methods to parse these emissions and separate crafted from organic radio origins. Routine scans of 3i Atlas over wide signal ranges have uncovered no clear crafted broadcasts. Even as studies persist with the entity drawing nearer to our world, the lack of spotted outreach fails to rule out engineered routes, given that superior societies might employ unheard-of outreach techniques or bands outside our watch. The alignment idea pushes notions of crafted origins further, proposing that our 7 long-standing icy visitors form a deliberate group reacting to 3i Atlas's presence. This notion demands vast leaps in assumptions regarding cutting-edge capabilities and tactical schemes spanning vast cosmic gaps. Every piece in our icy cluster would require self-contained drive and steering systems advanced enough to synchronize arrivals in tight schedules. The planning for such unity strains our conceptual bounds. 7 distinct items dispatched from varied starting points across differing timelines, all converging mere months apart following voyages lasting thousands of years. Nevertheless, the path traits of our 7 long-standing icy visitors bear unmistakable marks of birth within our star's domain. Their makeups fit anticipated models for items born in our system's distant reaches. Their finding records link to established observation efforts that have followed these items for years or even generations. Their routes display no hints of deliberate path tweaks or unified actions. Should these items prove to be crafted forms, they would demand extraordinarily refined disguise efforts aimed at flawlessly echoing genuine star system icy wanderers. Such ruse would necessitate in-depth. This implies a level of insight into human observational tools and predictions that points to monitoring and evaluation skills, surpassing what their visible tech advancements show. The link in schedules between 3i Atlas and the cluster of comets stands as the most compelling case for deliberate synchronization. Though the process behind it stays mysterious, examining stats on how comets show up might uncover if the gatherings in 2025 mark a truly odd bunching that goes past what we'd expect from pure chance spreads. Yet, just matching timelines offers slim support for deliberate human-made links, especially when weighed against growing detection tech and the normal ups and downs in spotting comets. The spread of machine-driven scans of the heavens sharply boosts the odds of finding items that earlier eras might have overlooked entirely. The draw of ideas involving outsiders taps into our core urges to spot intent and smarts in what looks like pure luck. Confronted by odd alignments, people tend to lean toward ideas of purposeful action over admitting that randomness crafts designs that seem significant yet lack real ties. Theories of visitors from afar also ease modern worries over our solitude in the cosmos and the bounds of our inventions. Should superior societies be dropping by our star system, it hints that solitude isn't our fate and that progress in tech can leap past today's limits. Still, bold assertions demand solid backing, and notions of extraterrestrials fit that bold mold perfectly. Those pushing such views must show crafted traits that hold up under doubting review, not force doubters to disprove the absence of faint traces. What we've seen through telescopes so far falls short of backing claims of made-by-others origins for 3I Atlas itself or for pieces of the Comet group. True, we can't fully dismiss clever hiding tricks that flawlessly copy everyday space rocks, but those ideas lean on guesses about otherworldly skills and drives that stretch way past what facts we have. Efforts to probe continue, since better looks could spotlight features our present checks have skipped. Nearer passes will allow finer breakdowns via light spectra, sharper pictures, and keener hunts for crafted broadcasts or odd movements. Experts in stargazing hold a fitting doubt toward wild ideas, all while pressing on with steady watching and breakdowns that might catch real signs of creation if they're there. Rigorous science offers ways to sort idle hopes from true finds when used right. Hunting for minds beyond Earth ranks among the deepest puzzles for our kind. Should proof surface showing 3I Atlas or linked items display clear crafted signs, that find would reshape how we see our spot among the stars. Yet, without meeting the tough bars to sway wary experts, outsider theories stay in the realm of guesswork, not proven truth. The awe and potential endure, even as we note that today's sightings tilt toward everyday answers over strange ones. While we delve into wilder tales that minds have spun from this odd year of comets, keep in mind that sticking to science's discipline doesn't mean ditching interest in options that shake old views. The cosmos has shocked us in the past with events that once looked beyond belief. Part 13. The Doomsday Scenario. The Darkest. The portrayal of our 7 comets alignment in 2025 depicts a period of existential peril to society masterminded by powers outside humanity's grasp. Such an apocalyptic tale recasts the laws of heavenly motion as interstellar conflict, converting frozen debris and stone into instruments that could erase our species' legacy. Although these visions craft engaging stories, appraising their validity demands a candid review of tangible dangers against the emotional anxieties linked to rare sky phenomena. Authentic collision dangers adhere to established scientific principles, enabling exact computations of strike odds and outcomes. As rocky bodies or icy wanderers near our world along courses potentially crossing its orbital route, expert skywatchers forecast and address situations through unerring numerical methods. The principles of path dynamics directing these evaluations function with mechanical exactness, offering no space for doubt regarding true strike dangers. Not a single one among our 7 comet performers traces paths presenting any strike danger to our planet amid their ongoing passages. Pan-STARRS, SWAN, Stereo, Atlas K1, Atlas G3, Lemon, and NEAT each hold positions at secure separations spanning millions of kilometers. Their nearest passes keep them well outside the pull fields that might spark disastrous clashes. 3I Atlas pursues a parabolic path that guides it harmlessly beyond key bodies in the Sun's domain. Its birth from beyond our system in swift pace compared to local items, in fact, diminish strike chances instead of amplifying them. With capture by gravity unfeasible for items at parabolic velocities, the lack of strike peril fails to rule out every danger tied to heightened icy visitor surges. Disruptions in space climate fueled by peak sun phases can endanger tech foundations in manners that today's society finds hard to handle. Power distribution networks, orbital relay setups, and guidance webs all encounter weaknesses amid eras of fierce sun-flung particle assaults. However, these tech perils arise from sun processes, not icy visitor actions. Our sun's 11-year polarity rhythm hits peak strength in 2025, regardless of incoming icy visitors. The overlap in schedules between lively comets and lively sun states mirrors a joint reaction to the sun system's rhythms, not influence running from comets to sun patterns. Gauging peril calls for data-driven scrutiny that distinguishes real dangers from the sort of random groupings that seem significant to our minds wired for spotting designs. As various slim chance occurrences happen at once, gut-level peril judging typically inflates the odds of some unified and menacing development underway. Expert peril scrutiny uses numerical structures that handle the issues of testing many links at once when probing lots of possible ties among event kinds. In probing numerous potential bonds across varied happenings, certain seeming designs arise solely from luck, irrespective of real cause-effect links. The apocalyptic vision builds mental pull by grouping our 7-comet cluster alongside 3I Atlas as one menacing whole, instead of viewing each as a standalone occurrence. Such grouping shifts 7 distinct minor peril happenings into a seemingly major peril crisis, urging urgent worry and readiness. Still, path dynamics ignores this contrived grouping. Every item charts its unique course, shaped by pull forces acting separately on each icy wanderer. The seeming unity lies in how humans see things, not in tangible fact, born from when we observe rather than true exchanges among items. Historical precedent. This discussion sheds light on the connections between rare sky occurrences and earthly calamities. Throughout documented annals, vivid comets have materialized amid eras of conflict, epidemics, scarcity, and societal turmoil. Yet, thorough examination shows no meaningful link in statistics between these comet sightings and heightened instances of human misery. The illusion of such links stems from how striking heavenly displays gain amplified focus when societies are already burdened by ground-based woes. Records from turbulent epochs tend to highlight any odd sky happenings that appear tied to prevailing hardships. In contrast, comparable celestial displays happening in tranquil times draw far scantier documentation. Contemporary society confronts authentic perils to its very existence, warranting focused scrutiny. Atomic conflict, global warming, infectious outbreaks, and tech upheavals each present true dangers to humanity's well-being. Such dangers function via clear-cut processes amenable to study, simulation, and possible alleviation via fitting strategies and readiness measures. The notion of an apocalyptic comet diverts focus from these tangible perils by fixating on occurrences that offer scant real peril to societal fabric. Diverting scarce focus and assets to fanciful dangers diminishes our shared capacity to tackle substantive issues, demanding ongoing commitment and unity. Outlandish assertions regarding stellar dangers require stricter proof thresholds than offhand musings on peculiar alignments. If a person claims that our cluster of comets endangers society on a grand scale, demands arise for precise processes, measured likelihoods, and confirmable proof from neutral sources, not mere hints at eerie schedules. Science's approach offers tools for impartial appraisal of such propositions, testing ideas, crunching numbers for patterns, and expert scrutiny aid in separating valid worries grounded in facts from baseless anxieties driven by mental tendencies over material perils. Agencies geared for crisis response operate advanced surveillance networks to follow real cosmic weather dangers and gauge their effects on vital setups. These networks would spot and alert on any true perils from ramped-up comet presence or peak sun activity well ahead of any unfolding. No alerts from bodies overseeing cosmic weather strongly counters tales of looming tech breakdowns sparked by comet-linked events. Experts in hazard evaluation, drawing on fullest data streams, find zero signs of exceptional dangers needing urgent action. Spreading knowledge on true cosmic weather perils fosters balanced views on the gap between flashy displays and actual perils. Sun flares truly can endanger tech networks, though their dangers follow familiar paths open to forecasting, oversight, and countering via design fixes. The stepped-up comet buzz in 2025 promises dazzling viewing chances and key insights into solar system motions. Such gains vastly surpass any practical perils tied to the viewing acts. True peril emerges when baseless dreads eclipse valid wonder in science and learning prospects. Ethical sharing of science calls for candid recognition of unknowns, all while holding steady gauge on the true measure of perils. As we concede that parts of our comet probe stay puzzling, it's vital to stress that puzzling equates not to perilous. The cosmos routinely yields events that test prevailing knowledge sans urgent dangers, threats posed to human society. Scientific advancement relies on methodical exploration of such occurrences, steering clear of hasty judgments rooted in partial data or mental predispositions. As we gear up to scrutinize the most intricate plots devised by human ingenuity concerning our peculiar year of comets, keep in mind that bold assertions regarding interstellar perils demand robust proof to warrant thoughtful scrutiny. Speculation driven by dread offers little value when detached from thorough evaluation of real likelihoods and processes. The apocalyptic vision uncovers more about the workings of the human mind than about the principles of celestial mechanics. Our minds, wired to detect patterns, tend to view groupings of odd happenings as orchestrated dangers instead of mere chance alignments, especially amid societal tensions when people eagerly hunt for reasons behind their worries. Yet, the cosmos functions via immutable physical rules that pay no heed to mortal apprehensions or anticipations. Comets trace paths governed by gravity, paths we can compute with accuracy. Solar flares adhere to magnetic rhythms forecastable through stats, and space weather impacts conform to electromagnetic rules we can gauge and simulate. The grand celestial mechanism persists in its exact rhythm, untouched by the sensational tales we weave about its most striking displays. Grasping this mechanism yields tangible advantages and a deep fulfillment that outlasts the fleeting excitement of end-times fantasies. Part 14, The Invasion in Disguise. The grandest plot theory linked to our 7-comet occurrence posits that we are observing the opening stage of an alien incursion masked as ordinary sky spectacles. In this outline, 3I Atlas functions as a flagship, directing a squadron of items posing as classic comets while scouting and readying for ultimate takeover of our star system. This takeover idea calls for tech prowess that defies human comprehension. Every supposed scout must possess masking tech refined enough to flawlessly imitate the light spectra, vapor release patterns, and path features of authentic inner solar system wanderers. Achieving such trickery would necessitate profound insight into our sky-watching tools and a thorough grasp of how true comets act when warmed by the sun. Ponder the design hurdles in building fake entities able to deceive our top-tier detectors. Today's spectral analysis can pinpoint chemical compounds with remarkable accuracy, spotting differences in atomic variants that betray origin settings and reactions. Any man-made scout would have to transport substances precisely mirroring those anticipated for relics born in our distant solar reaches eons back. The vapor emission that forms comet streams imposes similar tough masking demands. Real comets gain their signature look via the shift from solid to gas of icy stuff under sunlight, a sequence tied to their core makeup, and heat traits honed across vast epochs. Faking this convincingly would call for intricate design to echo these traits believably. Brightness profiles, the shifts in glow that define comet actions, offer yet another way to spot man-made routes. Authentic comets usually display gradual light shifts, broken by sporadic flares when new icy layers surface. The spin cycles shown by these glow shifts echo the innate wobbling of lopsided forms with loose gravitational holds. If our 7 classic comets were fabricated devices, their light curves ought to eventually expose traits that set engineered actions apart from those occurring naturally. Signs like rotation under artificial command, brightness shifts occurring at exact intervals, or indications of deliberate orientation adjustments would surface via ongoing photometric observations. For probes meant to masquerade, their paths around the Sun pose the core issue in blending in. Every piece in this group of comets adheres to a route that stretches back across eons of pulls from gravity. Such paths embed marks from where they originated, brushes with planets, and tugs from gravity that molded their present courses. To fabricate man-made items whose orbits blend seamlessly with those of genuine denizens of our solar system, one would need to propel them from suitable ranges and angles, all while aligning their arcs to fit what we'd anticipate from bodies born in particular zones of the distant solar system. The practicalities of pulling off such a feat over vast gaps between stars and spans rivaling Earth's deep history defy easy grasp. Additionally, the tales of how our 7 comets came to light link to established tracking efforts that have followed these bodies for years or even decades. Surveys like NetLemmon and Atlas hold detailed records capturing the details of each find and the follow-up calculations of orbits that pin down when they're due to arrive. Should these turn out to be fresh arrivals crafted by intent instead of long-haul comets finishing their innate loops, their abrupt entry into observation logs would have sparked swift scrutiny from experts in path studies. With no such warning sounding, this stands as a robust case against ideas of lately placed fakes posing as classic comets. Coordinating an assault group brings further chances to spot them through their chatter. Keeping 7 spread-out items in sync, alongside a lead ship, demands steady info swaps via radio waves, laser beams, or various energy waves that ground-based watchers might snag. Folks hunting for signs of alien minds run advanced dish arrays that scan wide swaths of the heavens nonstop for made-up signals, efforts such as Project Breakthrough. Listen, holdovers from Arecibo Observatory, and many more keep up steady hunts for the precise sorts of crafted pulses needed to link parts of an attacking armada. Not picking up any such pulses tied to our comet cluster doesn't rule out every way to talk, as superior societies could use tricks we can't yet sense. Still, the needs for syncing a fleet's moves over solar system expanses would probably call for pulse intensities and rhythms that our tools today could catch. The reasoning behind hidden assault plans runs into basic puzzles on value for effort and handling dangers. For what reason would star-spanning societies opt for such intricate ruses, given that a straightforward entry could scout goals with less hassle? In what way does hiding offer an edge when the aimed-at society holds no shields against starfaring tech? The outlay in assets to build and send out 7 clever disguise scouts on top of a directing craft would dwarf humanity's total wealth by huge multiples. Societies advanced enough for those outlays would hold tech edges so vast that trickery loses all point in strategy. On top of that, the assault idea presumes malice. No signs of hostile intent emerge from the behaviors exhibited by any of the identified celestial bodies. Every element in our comet cluster displays only the attributes expected from ordinary cosmic materials. Notably, 3I Atlas pursues an exit path that ensures its eternal exit from the solar system, a course scarcely aligned with any plan to secure a lasting foothold for conquest. The allure of conquest narratives stems from modern worries over tech upheavals, battles for scarce resources, and the erosion of human autonomy against advanced powers. Such apprehensions cling easily to bizarre sky events that hint at influences defying human oversight or comprehension. Yet, imaginative guesses about alien motives fail to replace solid data on the essence and actions of these spotted entities. Theories of assault demand concrete signs of engineered traits, synchronized movements, or aggressive potentials, instead of depending on the lack of confirmation that these items are purely organic. Existing records from observations offer zero backing for notions of manufactured beginnings in connection with any part of our comet cluster. Spectral examinations uncover makeups that align with organic origins within solar system settings. Path dynamics conform to projections for bodies shaped by gravity's long-term pull across eons. Activity trends reveal nothing pointing to deliberate guidance or linkage except for chance alignments in numbers. Those advancing bold assertions bear the onus to show engineered features that withstand thorough doubting scrutiny. Lacking that proof doesn't confirm the impossibility of conquest tales, yet it strongly suggests that present sightings lean toward standard stargazing interpretations rather than outlandish options. Experts in celestial studies uphold steady watch over all odd sky wanderers, exactly to spot traits that could signal crafted origins. The field regards these prospects with gravity, upholding set procedures for assessing possible alien relics while enforcing fitting proof thresholds to separate guesswork from valid breakthroughs. Scrutiny persists as nearer passes allow finer probes into entity traits and motions. Should true crafted markers be present, they ought to stand out clearer with advancing viewing tools and growing info stores as moments pass. Tales from speculative fiction play useful roles in probing what-ifs and building mental scaffolds for startling finds. However, their amusement factor offers no excuse for pushing unproven stories as settled truths amid the facts at hand. Proofs fall short in upholding wild assertions. The vast expanse holds plenty of real enigmas, sparing us the need to fabricate extra riddles from hopeful delusions or panic-fueled guesses. This cluster of 7 comets stands as a valid oddity in stats, meriting close study. Still, such study must chase clues, not preset verdicts on armadas of attackers or stellar plots. In readying our roundup of probes, results, and verdicts, keep in mind that upholding methodical discipline need not mean forsaking awe at stellar unknowns. The instruments of fact-based probing, which sort truth from illusion, likewise equip us to spot true breakthroughs once compelling proofs emerge at last. The starry realm might still astonish with happenings that upend usual views, but those shocks will come via precise watching and dissection, not jumps of fancy past the proofs we hold. Part 15. The Swarm's Message. Following extended months of probing, charting path dynamics, dissecting by scrutinizing statistical likelihoods, and probing all possible links among 3i Atlas and our 7 Comet Parade, findings lead to a verdict that's both comforting and astonishing. What unfolds before us is a stunning display of nature's workings, not signs of unusual orchestration or alien meddling. The 2025 cluster of 7 comets embodies a true case of probabilistic grouping, drawing eyes exactly due to how infrequently such gatherings happen, lending them an air of purpose. Pan-STARRS, SWAN, Stereo, Atlas K1, Atlas G3, Lemon, and Neat trace separate courses through space, guided by pulls of gravity that molded their roots eons ago, well prior to any human society rising to behold their coming together. Still, brushing off this alignment as simple chance overlooks the deep allure and research worth in our current spectacle. Across the cosmos, stars have staged a grand skyward gathering, opening doors to rare chances for side-by-side comet analysis, outreach in stargazing for the masses, and richer insights into the far reaches of solar system motions. Though the schedule stems from nature alone, its ripple through science and society stays profoundly striking. 3. iAtlas brings yet another dimension of awe, serving as the initial thoroughly recorded wanderer from beyond our solar system, showing unmistakable traits of a comet. Bearing frosts and grains born near a distant sun, tempered over vast stretches of cosmic wandering. It now melts in our star's glow, weaving displays that reveal chemistry from afar to scopes everywhere on Earth. Researchers remain captivated by the overlap in timing between this outsider and what ranks as the busiest comet season lately. While data now leans toward happenstance over direct cause, the cosmos often crafts patterns that stir deep resonance via ordinary mechanisms, showing how random events and real import might overlap sans need for hidden forces. Probes uncover no ties and paths, odd actions, or schedule matches surpassing expectations from math models for separate bodies swayed just by standard pulls of gravity and sun warmth. Every comet narrates its unique tale, origins in the solar system's fringes, jolts from gravity that set its present loop, and reactions to rising sunlight as it nears closest solar approach. Far from lessening the thrill in science for 2025's odd sky bustle, this view heightens it. A bunch of vivid comets offers side-by-side views seldom seen in one watch window. Experts get to explore responses of varied makeups, scales, and path shapes to matching sun warmth, pushing comet science forward in manners lone sightings can't match. Heightened sun stirrings tied to peak cycle phases will boost the show of our comet lineup while yielding live labs in cosmic weather science. Those very blasts of solar crown material, risky to our tech setups, spark the vivid tail breaks and charged gas wobbles that turn comet snaps into must-see art amid lively sun times. From every corner of the globe, hobby stargazers capture this sky party in fine grain, building image troves to guide studies for years ahead. The spread of top-tier sky imaging tools lets droves of watchers feed info that bolsters pro-watch efforts, expanding sight power past any lone group's reach. Sparked by our 7-comet probe, widespread involvement shows how rare sky happenings ignite passion for cosmic knowledge and sharp reasoning. The process of assessing bold assertions alongside empirical data offers learning moments that standard stargazing education seldom delivers, illustrating the way empirical reasoning separates conjecture from verified truth. The lack of unusual links fails to rule out potential revelations down the line. Ongoing surveillance could uncover faint links overlooked by today's reviews, or nearer encounters might allow spotting traits still under current detection limits. Scientific advancement happens via gradual advances in data collection, accuracy, and interpretive methods, which from time to time expose once concealed occurrences. The grouping patterns seen in 2025 might yield understandings of enduring solar system movements spanning eras longer than recorded human history. Should such groupings have happened before or follow foreseeable cycles, they could signal orbital harmonies, sunspot rhythms, or further recurring forces molding comet schedules across vast cosmic periods. Experts in the field of astronomy persist in methodical tracking and examination of any odd bodies, staying alert for signs hinting at manufactured sources or strange natural behaviors. Researchers treat these prospects with gravity, yet enforce fitting proof requirements to tell real oddities, apart from chance variations in intricate datasets. Our probe's wider ramifications reach past the narrow issue of ties between 3I Atlas and conventional solar system comets. This approach highlights how thorough empirical probing handles outlandish ideas without succumbing to the buzz they stir in mainstream media. Striking a harmony between inquisitiveness and doubt grows ever more vital as online platforms boost dramatic stories quicker than thoughtful scrutiny can appraise them. Those in science hold a duty to share reliable details and admit gaps forthrightly, instead of vying with amusement-driven material via overblown statements or hasty judgments. The 2025 Comet episode further shows how our innate drive to spot designs can turn neutral sky happenings into personal tales of universal import. This shift holds no inherent flaw. Deriving purpose and awe from heavenly displays has fueled societies across ages, though it demands deliberate division of raw sightings from explanatory lenses. Contemporary astronomical instruments grant unmatched power to sort true irregularities from seeming designs born of routine chance spreads. These instruments also unveil vast cosmic events that outstrip mortal fancy, all without needing far-fetched accounts, proving that existence frequently outdoes inventive fancy. With our study wrapping up, a universe lingers that feels both clearer and more enigmatic than media tales imply. It runs by discoverable natural rules grasped via diligent watching. Still, those rules yield events that defy gut feelings and spur endless probing. Perhaps the core lesson from the 2025 cluster is that the cosmos supplies ample true marvels, sparing us the need to fabricate extra enigmas. 7 distinct comets aligning via ordinary mechanisms, joined by an extrasolar guest on its sole solar system traverse, forms a stellar alignment deserving acclaim for its sheer striking synchrony. The teaching worth of this event stretches well past stargazing into vital. These foundational abilities in reasoning extend universally throughout every field of human inquiry. Acquiring the knack for separating mere associations from true causal links, for scrutinizing assertions via fitting criteria of proof, and for balancing awe with a commitment to thorough scrutiny equips us with cognitive instruments that benefit civilization far outside the narrow realm of probing comet clusters. Looking ahead, posterity might regard 2025 as a pivotal moment, one where enhanced detection technologies merged with the amplifying power of online networks to elevate everyday celestial findings into widespread cultural events, drawing in millions of dedicated enthusiasts globally to debate the odds of evidence and the essence of empirical wisdom. In the end, the cluster's core takeaway could lie in emphasizing our innate inquisitiveness and sharp deductive prowess over any fanciful alignment of stellar bodies as the true highlights of this saga. Humanity has crafted instruments advanced to the point of spotting objects from beyond our solar system, determining their paths with remarkable accuracy, and dissecting bold propositions via stringent probabilistic methods. Such feats in engineering and cognition merit equal acclaim with the dazzling sky events we get to observe. Though the cosmos probably isn't conveying signals via synchronized comet influxes, it persists in offering chances for exploration that repay meticulous scrutiny with richer insights into our stellar surroundings. This probe wraps up as it started, embracing astonishment at the odd coincidences, honoring precise examination, and cherishing a cosmos brimming with genuine enigmas sufficient to fuel our exploratory spirit across countless generations. With the proposition examined, the data weighed, and the sense of marvel upheld, all remains ready for subsequent probes lying just past the limits of what we can presently see.